January 14, 1945. Obergefreiter Klaus Zimmermann of the 352nd Infantry Division pressed his face against the frozen earth of his foxhole near Hagenau, France. The American artillery had been pounding his position for what felt like hours, but something was different this time. The shells weren't exploding on impact with the ground as they always had. Instead, they detonated precisely 20 feet above his head, showering his position with a deadly rain of metal fragments that no amount of digging could protect against. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. In his final letter to his wife Maria, found 3 days later by advancing French forces, Zimmermann wrote words that captured the bewilderment of an entire generation of German soldiers. The American guns have learned to think. They know exactly where we are hiding, and they burst in the air like angry gods throwing lightning. Our bunkers mean nothing. Our trenches offer no shelter. It is as if they can see through the earth itself. What Zimmermann had encountered was the variable time fuse, a technological marvel that would revolutionize artillery warfare and leave German defenders psychologically shattered across every front. The VT fuse, also known as the proximity fuse, represented the convergence of American industrial might, scientific innovation, and tactical doctrine in a way that German military planners had never anticipated and could never hope to match. The story of German unpreparedness for the variable time fuse begins not in the muddy fields of Europe, but in the sterile laboratories of American universities and defense contractors in the early 1940s. While German scientists had explored proximity fuse concepts as early as 1938, their research remained theoretical, constrained by material shortages and competing priorities in a resource-starved war economy. The Reich's scientific community, brilliant as it was, operated under the assumption that such complex electronic devices would remain laboratory curiosities for decades. German artillery doctrine in 1939 had been built around precision, economy, and proven technology. The Wehrmacht's artillery arm prided itself on accurate time fuses that could be calculated to detonate at predetermined intervals, contact fuses for direct impact, and carefully rationed ammunition supplies that demanded every shell count. This philosophy emerged from Germany's experience in World War I, where artillery had evolved into a science of mathematical precision and methodical destruction. The German High Command's 1941 assessment of American artillery capabilities revealed a fundamental misunderstanding that would prove catastrophic. Intelligence reports from the Eastern Front and North Africa consistently portrayed American artillery as wasteful, inaccurate, and reliant on overwhelming firepower rather than tactical skill. German observers noted that American gunners seemed to fire 3 times as many rounds to achieve effects that German artillery could accomplish with careful calculation and superior training. This assessment wasn't entirely wrong in the conventional sense. American artillery doctrine did emphasize volume of fire over precision, but German analysts failed to grasp the revolutionary implications of this approach when combined with advanced technology. They saw waste where Americans saw innovation, viewing the abundant use of artillery as a symptom of tactical inexperience rather than industrial superiority. The first documented encounter between German forces and VT fuse-equipped American artillery occurred during the Anzio landings in January 1944, though German intelligence initially failed to recognize what they were facing. The 715th Infantry Division, defending the coastal approaches, reported unusual shell bursts to higher command, describing them as premature detonations caused by faulty American ammunition. Hauptmann Friedrich Weber, commanding the 2nd Battalion of the 715th, filed a report on January 25, 1944, that revealed the German military's inability to comprehend what they were witnessing. The enemy artillery demonstrates continued problems with ammunition quality. Approximately 30% of incoming rounds detonate before impact, suggesting manufacturing defects in their fusing systems. While this creates additional fragmentation effects, it indicates American industrial problems that may be exploited. Weber's analysis, shared throughout German defensive positions along the Italian coast, represented a catastrophic misunderstanding. What he interpreted as industrial failure was actually the first combat employment of the most sophisticated artillery fuse ever developed. The VT fuse didn't malfunction when it exploded 20 feet above ground. It performed exactly as designed, using miniaturized radar technology to detect the optimal detonation altitude for maximum anti-personnel effect. The technological sophistication of the VT fuse would have been incomprehensible to German forces even if they had understood its true nature. Each fuse contained a complete radar transmitter and receiver system, miniaturized to fit within a 105mm artillery shell. The device transmitted radio waves at 180 MHz, detecting reflections from the ground below and calculating the precise moment to detonate for maximum fragmentation coverage. American scientists at Johns Hopkins University's Applied Physics Laboratory had solved manufacturing problems that German researchers considered theoretically impossible under wartime conditions. The fuse required precision electronic components that had to withstand the enormous forces of artillery firing, accelerations exceeding 20,000 times the force of gravity, while maintaining the sensitivity to function properly upon approach to target. The production requirements for VT fuses revealed American industrial capabilities that left German intelligence analysts struggling to comprehend the implications. Each fuse required approximately 100 individual electronic components, including vacuum tubes smaller than a man's thumb, precision resistors, and miniaturized capacitors that had to function reliably after experiencing forces that would destroy conventional electronics. The production requirements for VT fuses revealed American industrial capabilities that left German intelligence analysts struggling to comprehend the implications. Each fuse required approximately 100 individual electronic components, including vacuum tubes smaller than a man's thumb, precision resistors, and miniaturized capacitors that had to function reliably after experiencing forces that would destroy conventional electronics. By mid-1944, American factories were producing VT fuses at rates that staggered German observers. The Eastman Koda Company, Sylvania Electric, and Crosley Corporation had been converted from consumer electronics production to VT fuse manufacturing, achieving production rates of approximately 100,000 fuses monthly by the summer of 1944. Total wartime production would eventually exceed 22 million units, representing an industrial achievement that Germany could never match. German attempts to capture and analyze VT fuses met with limited success due to built-in security measures that American designers had incorporated. The fuses contained self-destruct mechanisms that rendered them inoperable if they failed to detonate properly, preventing German forces from acquiring intact examples for reverse engineering. When German scientists did obtain fragmentary remains, the miniaturization and complexity of the components defied their manufacturing capabilities. The psychological impact of VT fuse artillery became apparent during the breakout from Normandy in July and August 1944. The 353rd Infantry Division, defending the approaches to Falaise, experienced the full fury of American artillery equipped with proximity fuses for the first time in sustained combat. Veterans of the Eastern Front, accustomed to Soviet artillery that followed predictable patterns, found themselves facing a weapon that seemed to possess supernatural intelligence.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means
Unteroffizier Hans Bergmann, a squad leader with the 353rd who survived the Falaise encirclement, described his first encounter with VT fuse artillery in a post-war interview. "We heard the familiar whistle of incoming shells and took cover in our prepared positions. The shells arrived exactly as expected, but instead of exploding harmlessly in the dirt above our heads or penetrating deep before detonation, they burst at the perfect height to shower us with metal. It was as if each shell could see us hiding and knew exactly when to explode." The tactical implications of VT fuse technology became clear as German forces attempted to adapt their defensive strategies. Traditional artillery defense relied on overhead cover, deep foxholes, and dispersed positions that minimized casualties from ground-burst shells. The VT fuse negated these protective measures by ensuring optimal airburst effects regardless of terrain or defensive preparations. German field manuals, revised hastily in late 1944, attempted to address the VT fuse threat with recommendations that revealed the Wehrmacht's desperation. Suggested countermeasures included deeper excavations, thicker overhead cover, and wider spacing between defensive positions. But these modifications required resources and time that German forces increasingly lacked.
The Battle of Metz in September and October 1944 demonstrated the VT Fuze's effectiveness against prepared fortifications that should have provided adequate protection against conventional artillery. The 462nd Volksgrenadier Division, defending the ancient French fortress city, had prepared positions that incorporated both World War I-era fortifications and modern improvements designed to withstand sustained bombardment. American forces approaching Metz employed VT Fuze-equipped 105mm and 155mm howitzers in concentrated bombardments that achieved effects previously requiring much larger caliber weapons. The proximity fuses ensured that shells detonated at optimal heights above German positions, creating fragmentation patterns that penetrated defensive works from angles that contact fuses could never achieve. Generalmajor Heinrich von Schultitz, commanding the Metz garrison, reported to Army Group G headquarters that American artillery had achieved unprecedented effectiveness against prepared positions. His message, intercepted and decoded by Allied intelligence, revealed German confusion about American capabilities. Enemy artillery demonstrates accuracy and lethality that exceeds our calculations. Positions constructed according to regulation provide inadequate protection. Request guidance on defensive modifications. The response from higher headquarters demonstrated the German High Command's continued failure to understand what they faced. Army Group G recommended increased overhead cover and deeper excavations, standard responses to conventional artillery threats that proved useless against VT Fuze technology. German defensive doctrine, based on decades of experience with contact and time fuses, had no answer for shells that could think. The industrial disparity between American VT Fuze production and German capabilities became a source of strategic despair among Wehrmacht planners who understood the implications. German attempts to develop comparable proximity fuse technology, designated the Kranisch project, achieved limited laboratory success but never reached production due to material shortages and competing priorities. German scientists working on proximity fuse development reported to the Reich Ministry of Armaments that American VT fuses represented an industrial achievement requiring resources that Germany simply didn't possess. The miniaturized electronics demanded precision manufacturing equipment, rare metals, and quality control standards that German wartime industry couldn't maintain while simultaneously producing conventional weapons in sufficient quantities. Dr. Wilhelm Steinhoff, leading German proximity fuse research at Peenemünde, submitted a report in November 1944 that captured German technological disadvantage with stark clarity. American proximity fuses demonstrate manufacturing precision and electronic sophistication that suggests unlimited access to strategic materials and production capacity. Replication would require diverting resources from current weapons programs while providing no guarantee of successful mass production. The failure of German technology to match American VT Fuze capabilities represented more than a tactical disadvantage. It symbolized the broader industrial and scientific disparity that increasingly dominated the war's outcome. German forces found themselves facing weapons that embodied American technological superiority in concentrated, devastating packages delivered by artillery batteries that seemed to possess unlimited ammunition supplies. The most psychologically devastating aspect of VT Fuze technology was its seeming intelligence. German soldiers, trained to understand artillery as a mechanical, predictable force, struggled to comprehend shells that appeared to make decisions about when and where to explode. This perceived intelligence transformed artillery from a natural hazard to be endured into a malevolent force that actively hunted defenders in their positions. The sound of VT Fuze-equipped shells became embedded in German survivors' memories as distinctly different from conventional artillery. The characteristic crack of an airburst detonation, sharper and more immediate than ground explosions, announced the arrival of weapons that German defensive doctrine couldn't counter. Veterans described learning to recognize the approach of VT rounds by their flight characteristics, though such knowledge provided no protection. German medical units reported casualty patterns that reflected VT Fuze effectiveness with clinical precision. Where conventional artillery produced injuries concentrated among exposed personnel and those in inadequately protected positions, VT Fuze shells created casualties even among troops in properly constructed defensive works. The omnidirectional fragmentation pattern of optimally timed airbursts reached defenders regardless of their protective measures. The 116th Panzer Division, defending approaches to the Rhine in early 1945, experienced VT Fuze artillery during American river crossing operations that demonstrated the technology's tactical revolution. Division medical personnel noted that artillery casualties no longer correlated with the quality of defensive positions. Even experienced soldiers in well-constructed bunkers suffered wounds from fragmentation that seemed to find every weakness in their protection. Generalmajor Heinrich von Scholtitz, commanding the Metz garrison, reported to Army Group G headquarters that American artillery had achieved unprecedented effectiveness against prepared positions. His message, intercepted and decoded by Allied intelligence, revealed German confusion about American capabilities. Enemy artillery demonstrates accuracy and lethality that exceeds our calculations. Positions constructed according to regulation provide inadequate protection. Request guidance on defensive modifications. The response from higher headquarters demonstrated the German High Command's continued failure to understand what they faced. Army Group G recommended increased overhead cover and deeper excavations, standard responses to conventional artillery threats that proved useless against VT Fuze technology. German defensive doctrine, based on decades of experience with contact and time fuses, had no answer for shells that could think. The industrial disparity between American VT Fuze production and German capabilities became a source of strategic despair among Wehrmacht planners, who understood the implications. German attempts to develop comparable proximity fuse technology, designated the Kronich project, achieved limited laboratory success but never reached production due to material shortages and competing priorities. German scientists working on proximity fuse development reported to the Reich Ministry of Armaments that American VT fuses represented an industrial achievement requiring resources that Germany simply didn't possess. The miniaturized electronics demanded precision manufacturing equipment, rare metals, and quality control standards that German wartime industry couldn't maintain while simultaneously producing conventional weapons in sufficient quantities. Dr. Wilhelm Steinhoff, leading German proximity fuse research at Peenemünde, submitted a report in November 1944 that captured German technological disadvantage with stark clarity. American proximity fuses demonstrate manufacturing precision and electronic sophistication that suggests unlimited access to strategic materials and production capacity. Replication would require diverting resources from current weapons programs while providing no guarantee of successful mass production. The failure of German technology to match American VT Fuze capabilities represented more than a tactical disadvantage. It symbolized the broader industrial and scientific disparity that increasingly dominated the war's outcome. German forces found themselves facing weapons that embodied American technological superiority in concentrated, devastating packages delivered by artillery batteries that seemed to possess unlimited ammunition supplies. The most psychologically devastating aspect of VT Fuze technology was its seeming intelligence. German soldiers, trained to understand artillery as a mechanical, predictable force, struggled to comprehend shells that appeared to make decisions about when and where to explode. This perceived intelligence transformed artillery from a natural hazard to be endured into a malevolent force that actively hunted defenders in their positions. The sound of VT Fuze-equipped shells became embedded in German survivors' memories as distinctly different from conventional artillery. The characteristic crack of an airburst detonation, sharper and more immediate than ground explosions, announced the arrival of weapons that German defensive doctrine couldn't counter. Veterans described learning to recognize the approach of VT rounds by their flight characteristics, though such knowledge provided no protection. German medical units reported casualty patterns that reflected VT Fuze effectiveness with clinical precision. Where conventional artillery produced injuries concentrated among exposed personnel and those in inadequately protected positions, VT Fuze shells created casualties even among troops in properly constructed defensive works. The omnidirectional fragmentation.
The technical specifications of the variable time fuse revealed engineering achievements that left German scientists questioning fundamental assumptions about wartime manufacturing possibilities.
Each VT fuse measured exactly 5.1 inches in length and 3.5 inches in diameter, containing sophisticated electronic components that had been miniaturized to unprecedented scales. The primary vacuum tube, designated the 6AK5, measured barely 0.8 inches in height, yet contained all necessary elements for radar transmission and reception within a single glass envelope. American engineers at Bell Laboratories and the Massachusetts Institute of Technology had solved problems that German researchers considered theoretically impossible under combat conditions. The fuse transmitted continuous wave radar signals at 180 MHz while simultaneously processing reflected signals to calculate optimal detonation timing. This dual function required electronic circuitry that could withstand artillery firing forces exceeding 20,000 times normal gravity while maintaining the sensitivity to detect ground reflections at distances measured in mere feet. The manufacturing precision required for VT fuse production challenged every aspect of American industrial capacity in ways that German observers initially dismissed as impossible. Each fuse contained approximately 200 individual components, including resistors with tolerances measured in thousandths of an ohm, capacitors rated for specific frequencies, and induction coils wound to exact specifications. The assembly process demanded quality control standards that German wartime production, operating under constant material shortages and labor constraints, could never achieve. Production statistics for VT fuse manufacturing revealed American industrial mobilization on scales that German intelligence analysts struggled to comprehend. The Eastman Kodak Company, previously known for photographic equipment, had converted entire production facilities to fuse manufacturing, achieving daily output rates of 3,000 completed units by early 1945. Sylvania Electric Products, Crossley Corporation, and General Electric had similarly transformed their operations, creating a production network capable of delivering VT fuses faster than American artillery could expend them. The economic implications of VT fuse production provided German planners with sobering insights into American resource allocation. Each fuse cost approximately $18 to manufacture in 1944, equivalent to $280 in contemporary currency, representing material investment that exceeded the monthly salary of German factory workers. American forces routinely expended thousands of VT fuses in single bombardments, consuming resources in individual battles that matched German artillery budgets for entire divisions. Quality control procedures for VT fuse production demonstrated American attention to detail that German mass production techniques couldn't replicate. Each fuse underwent 17 separate testing procedures during assembly, including electronic function checks, vibration tests simulating artillery firing stresses, and calibration procedures ensuring proper radar frequency operation. Rejected fuses, approximately 3% of total production, were completely disassembled for component analysis to identify and eliminate manufacturing defects. German attempts to reverse engineer captured VT fuses revealed the technological gap between American and German electronic manufacturing capabilities. The few intact examples recovered by German technical intelligence showed component miniaturization that required manufacturing equipment unavailable in occupied Europe. The vacuum tubes used in VT fuses demanded precision glassworking techniques that German electronics producers had abandoned early in the war to concentrate on simpler, more durable designs suitable for mass production under wartime constraints. Dr. Fritz Vollmer, leading German proximity fuse research at the Telefunken Laboratories, submitted detailed analysis reports to the Reich Ministry of Armaments throughout 1944 that documented German inability to match American VT fuse technology. His December 1944 assessment concluded that successful replication would require complete reorganization of German electronics production, diverting resources from radar and communication equipment manufacturing while offering no guarantee of achieving American production rates or reliability standards. The Battle of the Bulge in December 1944 provided German forces with extensive exposure to VT Fuze artillery effects under conditions that initially seemed favorable for German defensive tactics. The dense Ardennes forests and harsh winter weather should have limited American artillery effectiveness, but VT Fuze technology proved adaptable to terrain and environmental conditions that neutralized conventional artillery advantages. American artillery units supporting the defense of Bastogne employed VT fuses in tree burst mode, using forest canopy to enhance fragmentation effects against German infantry advancing through wooded terrain. The proximity fuses detected treetop reflections and detonated shells at optimal heights above German positions, creating deadly airbursts that showered attackers with metal fragments and wooden splinters from shattered trees. Oberst Wilhelm Osterhold, commanding artillery for the 26th Volksgrenadier Division during attacks on Bastogne's perimeter, reported artillery effects that exceeded German calculations for heavily forested terrain. His January 1945 after-action report described American defensive fires that achieved casualty rates 3 times higher than German doctrine predicted for similar bombardments in wooded areas. The Siege of Bastogne revealed VT Fuze effectiveness in defensive operations, where American forces used proximity fuses to create protective barriers around critical positions. American artillery units, despite being surrounded and outnumbered, maintained defensive fires using VT fuses that prevented German forces from achieving decisive infantry assaults. The psychological effect of accurate airburst artillery, combined with ammunition shortages that forced German units to conserve their own artillery fires, created tactical imbalances that contributed significantly to German offensive failure. German medical units treating casualties from VT Fuze artillery during the Ardennes offensive documented wound patterns that differed markedly from conventional artillery effects. The omnidirectional fragmentation created by optimal airburst detonations produced multiple wounds per casualty, overwhelming German field hospitals already strained by combat losses and supply difficulties. Sanitätsoffizier Dr. Werner Kempe, serving with the 12th SS Panzer Division during the Bulge offensive, noted in medical reports that VT Fuze casualties required significantly more medical resources than conventional artillery wounds. The multiple fragment wounds typical of proximity fuse effects demanded surgical procedures that German field medical units, operating with limited supplies and personnel, couldn't adequately address. The logistical requirements for VT Fuze employment demonstrated American supply capabilities that German forces found increasingly incomprehensible as the war progressed. American artillery batteries received VT fuses in wooden crates containing 24 rounds each, with instructions specifying optimal employment conditions for different target types and terrain features. This standardization and abundance contrasted sharply with German ammunition supplies that required careful rationing and selective targeting to maintain artillery effectiveness. American ammunition trains delivering VT fuses to forward artillery positions represented logistical achievements that German observers documented with a mixture of professional admiration and strategic despair. Single ammunition convoys contained more VT fuses than German artillery units received conventional rounds in monthly allocations, revealing supply capabilities that enabled tactical approaches impossible within German resource constraints. The Rhine River crossings in March 1945 showcased VT technology in river assault operations, where proximity fuses provided unprecedented support for amphibious forces with accuracy and effectiveness that conventional time fuses couldn't achieve. German defenders of the Rhine fortifications faced artillery bombardments where every shell seemed precisely calibrated for maximum effect against their specific positions. The VT fuses detected optimal detonation heights regardless of terrain variations, bridge structures, or defensive works, creating consistent fragmentation patterns that neutralized German resistance more effectively than larger caliber conventional weapons. General Major Kurt von der Chevalerie, commanding the 89th Infantry Division defending Rhine crossing points, submitted reports to Army Group B describing American artillery effectiveness that exceeded German defensive calculations.
His March 15, 1945 message stated that American forces achieved artillery effects equivalent to weapons twice the caliber of guns actually employed, suggesting technological improvements that German intelligence had failed to identify. The tactical revolution created by VT Fuze technology extended beyond immediate battlefield effects to fundamental changes in artillery employment doctrine. American forces developed firing techniques specifically designed to maximize proximity fuse advantages, including coordinated time-on-target missions where multiple batteries fired simultaneously to create massive airburst concentrations over German positions. Time-on-target missions using VT fuses created artillery effects that German forces had never experienced, with hundreds of shells detonating simultaneously at optimal heights above defensive positions. These coordinated bombardments achieved surprise and devastation that left German survivors psychologically traumatized and tactically ineffective even when physical casualties remained manageable. German artillery doctrine, based on decades of experience with predictable fusing systems, had no effective response to American VT fuse employment. Counter-battery fire techniques relied on calculating enemy positions based on shell flight times and impact patterns, but VT fuse-equipped rounds provided no reliable impact signatures for German observers to track back to American gun positions. The 155mm VT fuse, introduced in late 1944, represented escalation of American proximity fuse technology that left German forces facing even more devastating effects from heavier artillery. The larger warhead, combined with VT fuse precision, created fragmentation patterns that covered significantly more area than 105mm rounds, while maintaining the accuracy and optimal timing that made proximity fuses so effective. German forces retreating through the Rhineland in early 1945 encountered 155mm VT fuse bombardments that achieved area denial effects previously requiring much larger artillery concentrations. Single batteries of American 155mm howitzers using proximity fuses could render entire road networks impassable, forcing German units into time-consuming detours that exposed them to additional artillery strikes and air attacks. The psychological warfare aspects of VT fuse employment became increasingly apparent as German forces experienced prolonged exposure to proximity fuse artillery. The seemingly intelligent behavior of shells that detonated at precisely the right moment to maximize casualties created superstitious fears among German soldiers who began to believe American artillery possessed supernatural targeting abilities. German troops developed fatalistic attitudes toward American artillery that reflected their inability to effectively protect themselves using conventional defensive measures. The knowledge that properly constructed foxholes and bunkers provided little protection against VT fuse effects undermined confidence in defensive preparations that had sustained German forces through years of combat on multiple fronts. Combat stress reactions among German forces increased dramatically in units repeatedly exposed to VT fuse artillery, with medical officers reporting psychological casualties that reflected terror of weapons that seemed to hunt defenders in their positions. The unpredictable timing and devastating effects of proximity fuse detonations created anxiety disorders that persisted even during periods when American artillery remained inactive. The urban warfare applications of VT fuse technology proved particularly devastating during American advances through German cities in the final months of the war. Proximity fuses provided optimal fragmentation effects in built-up areas where conventional artillery struggled to achieve consistent results due to building interference and irregular terrain features. The Battle of Cologne in March 1945 demonstrated VT fuse effectiveness in urban combat where American forces used proximity fuses to clear German defenders from buildings without requiring direct hits on specific structures. The airbursts created by VT fuses showered building interiors with fragmentation that reached German positions regardless of their protective cover within urban structures. German defenders in Cologne's Old City reported artillery effects that penetrated buildings through windows, doorways, and damaged roofing, while avoiding the structural damage that might provide cover from conventional groundburst shells. The precision timing of VT detonations created optimal fragmentation angles that maximized casualties while minimizing interference from urban obstacles. Oberstleutnant Heinrich Schaefer, commanding the 3rd Battalion of the 689th Infantry Regiment defending Cologne's Cathedral District, described VT Fuze effects in urban terrain as more devastating than conventional artillery bombardments using twice as many shells. His final report noted that American artillery achieved street-clearing effects using single batteries that previously required concentrated fires from entire artillery battalions. The industrial capacity required to sustain VT Fuze production at wartime scales revealed American manufacturing capabilities that German economic planners had fundamentally underestimated. Peak monthly production reached approximately 400,000 VT fuses by early 1945, representing electronic manufacturing achievements that exceeded total German radar and communication equipment production for entire years. Component suppliers for VT Fuze production included manufacturers across American industrial centers, creating supply networks that demonstrated the depth of American technological infrastructure. Vacuum tube production alone required coordination between glass manufacturers, metalworking facilities, and precision equipment producers operating at quality standards that German wartime industry had abandoned to maximize basic production volumes. The reliability statistics for VT Fuze performance exceeded German expectations for any complex electronic device operating under combat conditions. Field reports documented malfunction rates below 2% for VT fuses, compared to German proximity fuse prototypes that failed approximately 15% of the time during laboratory testing under controlled conditions. This reliability margin reflected American quality control procedures that German mass production techniques couldn't replicate, while simultaneously maintaining output rates necessary for military effectiveness. Each VT fuse underwent testing procedures that consumed more time and resources than German factories allocated to complete weapons assembly, revealing fundamental differences in manufacturing philosophy that contributed to technological disparities. German prisoners of war interrogated about VT Fuze effects consistently reported psychological impacts that exceeded physical casualties in determining unit combat effectiveness. The knowledge that American artillery could achieve precision effects regardless of defensive preparations created hopelessness that undermined German resistance even before bombardments began. Interrogation reports documented German soldiers' descriptions of VT artillery as shells that think or rounds that hunt, reflecting their inability to comprehend the technology within familiar military frameworks. This anthropomorphization of American weapons revealed the psychological distance between German conventional understanding and American technological capabilities. The strategic implications of VT technology extended beyond immediate tactical applications to demonstrate American capacity for technological innovation under wartime pressures. German intelligence assessments recognized that VT development represented coordinated efforts between universities, private industry, and military organizations that German scientific communities couldn't match, while simultaneously supporting existing weapons programs. The success of American VT Fuze development indicated systematic approaches to military technology that suggested continued advantages extending beyond current weapon systems. German technical intelligence reports warned that American technological capabilities demonstrated by proximity fuse development probably extended to other weapons projects that remained classified or undiscovered. As German forces retreated deeper into the Reich during spring 1945, encounters with VT Fuze artillery became daily reminders of technological obsolescence that contributed to strategic despair among military leadership. The weapons represented American advantages in industrial capacity, scientific resources, and manufacturing quality that Germany could never match while fighting a multi-front war with diminishing resources. The final accounting of VT employment against German forces revealed technological achievement that fundamentally altered artillery warfare while demonstrating American industrial capabilities that German planners had consistently underestimated. Total wartime production exceeded 22 million units, representing electronic manufacturing that surpassed German radar and communication equipment production throughout the entire war. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.